precision computer control, time-saving, cost-saving manufacturing techniques. These are only a few reasons why the aerospace industry is taking a closer look at a flexible alternative to cutting the stronger, lighter materials now being used in aircraft manufacturing. It's the Abrasive WaterJet technology, and it's one cut above. There are three basic criterion that govern the manufacturing of today's modern aircraft. Make them lighter, stronger, and more economically. Two of these criterion have been met with the use of lighter, stronger materials, such as reinforced composites, titanium, Inconel, and other alloys. But these materials are expensive to use, and the processes required to cut these materials generate a certain amount of waste that's also expensive, adding to the overall cost of the aircraft. In addition to this factor, these conventional methods, such as punch press, require time-consuming steps, such as the designing, manufacturing, and maintenance of dies used in the manufacturing process. Hundreds of man-hours can easily be consumed when a required engineering change means the simple redesign of a part. Time and money are also spent in performing such routine manufacturing tasks as deburring the edges of the part that has been routed or cut. This is why the Abrasive WaterJet technology has become a time-saving, flexible alternative to conventional two-dimension cutting applications. The principle of abrasive WaterJet cutting is fairly simple. The abrasive WaterJet cutter consists of a narrow stream of high-pressure water and abrasive garnet, traveling at more than twice the speed of sound. This creates a force great enough to cut through the hardest materials without the effects of heat. With this technology, it's possible to cut through thin materials as well as thicker materials. It's also possible with nesting software to group certain part configurations into nests and multiple nests, speeding up the manufacturing process even more and making better use of the material by reducing needless waste. While the principles behind WaterJet cutting are relatively simple, the basic WaterJet system itself is a little more complex. The system is composed of a water treatment filtration system, cutting head assembly, two-axis gantry, catcher tank, and a CNC controller. Water is first filtered through the water treatment filtration system to remove any contaminants that may be detrimental. It then passes to an intensifier, where the water pressure is raised to approximately 35 to 45 KSI. The pressurized water next enters the cutting head assembly, where it passes through the small opening in a sapphire jewel, an opening that can range in diameter from 10 to 14 thousandths of an inch. From here, the stream of water enters the mixing chamber, where abrasive grit is added. It is then forced under high pressure through a carbide nozzle that can range in diameter from 30 to 60 thousandths of an inch. The stream finally passes through the cutting table to a catcher tank, which dissipates the stream and collects the abrasive material. The heart of the abrasive WaterJet system is the Computer Numerical Controller Assembly, or CNC, which drives the two-axis gantry from a predetermined program. Programs can be loaded into the controller manually or by floppy disk. An integral part of the abrasive WaterJet system is the Camsco digitizing nesting system. This system is capable of generating numerical control programs from existing templates, Mylar drawings, or CAD files. Then nests parts together to get the maximum use of the material. This is especially important to subcontractors who manufacture components for major aerospace companies. The ability to swiftly adapt to engineering changes without the time-consuming and costly expense of retooling is an extremely important factor in the use of WaterJet manufacturing techniques. Add to this the fact that the operation produces excellent edge quality, which usually does not require additional trimming or deburring, and that the system is highly flexible and able to cut just about any type of material without the effects of heat. The bottom line is a system that is designed to meet the principal objectives of the aerospace manufacturing world. Build them lighter, stronger, and more economically. That's why abrasive WaterJet technology is taking a major role in the making of aerospace components. It's a flexible, time-saving technology that is truly one cut above.